Good evening all. Am I audible? Good evening everyone. Am I audible? Surya Prakash, good evening. Sesha, good evening. Samyuktha, good evening. Jaya, good evening. Am I audible? Are you able to hear me? Girish, good evening. Santosh, good evening. Yeah, okay. Preeta, good evening. Rija, good evening. Preeti, good evening. Sajal Sarkar, good evening. Dharani, good evening. Bhumika, good evening. Yeah, Raghav, good evening. Aishwarya, good evening. Guru Raj, good evening. Srinivas, good evening. Stephen, good evening. Yeah, I welcome you all to my session. Good evening, everyone. So, in today's session, we are going to see the introduction to ESP8266. So, shall we start? Shall we start the session? Are you ready? Yeah. Killer Tesla, good evening. Shall we move to the session? Okay, first. So first, what is an ESP8266 Node MCU? Do you have any idea about Node MCU? Microcontroller, do you have any idea about this? Have you gone through this name? Let me explain it. First, the ESP8266 is a low-cost Wi-Fi chip which is developed by Expressive Systems. So, it can be used as a standalone device or as a UART to Wi-Fi adapter to allow other microcontrollers to connect to a Wi-Fi network. For example, you can connect an ESP8266 to an Arduino to add Wi-Fi capabilities to your Arduino board. The most practical applications is using it as a standalone device. With the ESP8266, you can control inputs and you can control outputs as you would do with an Arduino, but with Wi-Fi capabilities. This is also same as Arduino, but here we have inbuilt Wi-Fi. So this means you can bring your projects online, which is great for home automation and Internet of Things applications. Is it clear? So now let's see why this ESP8266 is so popular. Because of its low cost. You can get ESP8266 boards starting at like rupees 250 to 500 depending on the model. And coming to low power, the ESP8266 consumes only very little power when compared with other microcontrollers, and you can even go into deep sleep mode to consume less power. And then coming to Wi-Fi, the ESP8266 can generate its own Wi-Fi network or connect to other Wi-Fi networks to get access to the internet. This means the ESP8266 can access online services to make HTTP requests or save data to the cloud. For example, it can also act as a web server so that you can access it using a web browser and be able to control and monitor your board remotely. And it also compatible with the Arduino programming language. Those that are already familiar with programming the Arduino board were happy to know that they can program the ESP8266 board in the Arduino style. And then compatible with MicroPython. You can program the ESP8266 with MicroPython firmware, which is re-implementation of Python 3, targeted for microcontrollers and embedded system. And then so now what can you do with an ESP8266? Here I gave the short list of what you can do with ESP8266, which are: you can create a web server to control inputs and outputs. You can create a web server to display sensor readings. You can send HTTP requests, you can control outputs, you can read inputs, and you can set interrupts. And also you can do data logging projects. You can communicate with third-party services, you can create web applications, you can send emails, notification, post tweets. So in the entire 30 days masterclass, we are going to do all of this. We are going to create web server, we are going to display the sensor readings into the web server, we are going to send HTTP requests, notification, emails, and everything. So now, ESP8266 12E Wi-Fi chip. This is the ESP8266 12E Wi-Fi chip. I am talking about chip, not development board. So first, coming to the processor, we have L106 32-bit RISC microprocessor, which is based on 10 silica diamond standard, which is 106 micro, which is running at 80 or 160 megahertz. And coming to memory, we have 32 KB instruction RAM, 32 KB instruction cache RAM, 80 KB user data RAM, and 16 KB ETS system data RAM. ETS is nothing but Erlang term storage, which is capable of storing large amount of data and offers constant time data access. And coming to Wi-Fi range, we have IEEE 802.11, and we have 17 GPIO pins, and we have serial peripheral interface bus, and we have I2C, I2S. So I2S is nothing but integrated inter-IC sound bus, which interfaces with DMA, which means sharing pins with GPIO. So I2C is used to connect for the general inter-IC communication like EEPROM or sensors. But coming to I2S, which is used only for audio devices. And then we have UART on dedicated pins, plus the transmit only UART can be enabled on GPIO 2. And we have 10-bit ADC, which is a successive approximation ADC. Now let's see the difference between ESP8266 and ESP32. Both are node MCU, right? So these are the difference between ESP8266 and ESP32. If you are taking microcontroller, in ESP8266 we have extensor single core 32-bit L106. But in ESP32 there is different. Extensor dual core 32-bit LX6 with 600 DM IPS. If you are taking ESP8266, there is no inbuilt Bluetooth, but in ESP32 there is inbuilt Bluetooth and BLE. BLE means Bluetooth low energy. And coming to frequency, 8266 have 80 MHz and ESP32 has 160 MHz. And coming to static RAM and flash, there is no inbuilt static RAM and flash in 8266, but in ESP32 we have. And coming to GPIOs, ESP8266 only have 17 and 32 has 34. And coming to pulse width modulation, we have 8 channels in 8266 and 16 channels in 32. And And in ESP8266 we have 2 SPI, 1 I2C, 2 I2S and 2 UART, which is Universal Asynchronous Receiver Transmitter. But in 32 we have 4 SPI, 2 I2C, 2 I2S, 2 UART. Coming to ADC, we have only 10 bit for 8266 and we have 12 bit for 32. And if you are taking ESP8266, there is no inbuilt touch sensor or temperature sensor, Hall effect sensor. But in 32, we have all these sensor in inbuilt. And these are the price. This is up to like 240 to 500 rupees and these are 500 to 1000 rupees, which is based on the model. Okay. So again, I am going to tell you that if you want to become a certified IoT engineer, then this is the right time to swap your masterclass into internship. So what are the benefits of this internship? You will get 30 days of live sessions, you will get 90 days of access to the records, and there are 8+ source code in IoT projects, and you can download all the presentations, and there is 6 mentor for your mastermind sessions. Every week you will be assigned to one mastermind class. In that class you can clear your doubts, you can ask questions to your mentor, and also you will get your internship confirmation letter, and then you will get your internship certification at last. So normally we charge for internship like 1500, but if you are using this coupon code, you will get discount fees. It is just for 799. So use this registration link to register and use this coupon code. You will get discount amount. And there are some projects you will get, which are smart street light using LDR and IR Sensor, monitoring soil moisturization using ASK sensor, gas leakage detection using Arduino IoT Cloud, and IoT based heartbeat monitoring system, and also BME 280 sensor readings to the real-time database, web-based remote serial monitor. You can sending email using SMTP, WhatsApp using what about API. So there are much more projects we are going to do in these 30 days masterclass. So again I am telling you, using this coupon code you can get discount amount for just only for 799. So use this registration link to register and get the discount amount. Okay. So now let's see the ESP8266 versions. So there are several versions of the ESP8266, the ESP01 and ESP12E. These two are the most popular versions. You will find a wide variety of development boards with ESP12E or 12F chips. Then coming to next. So this is the development board. Earlier we saw just chip, right? This is the chip and this is the development board. You just have a bare chip. But in development board you have multiple things. Let's see. So using bare chips or modules is not easy or practical. For learning, for testing and prototyping, you will want to use ESP8266 Node MCU development board. ESP is nothing but the module name. The board name is ESP8266. So these comes with all the needed circuitry to apply power, to apply code, easy access to the GPIOs, to connect sensors and actuators, and here you will get an antenna for the Wi-Fi signal and other useful features, right? So now let's see how to choose an ESP8266 development board. So there is a wide variety of ESP8266 board from different vendors. Roshan is asking like there is any exam for the internship. There is no exam for internship. So here, when looking for an ESP8266 development board, there are several aspects you need to take in account. What are they? These are: first, USB to UART interface and voltage regulator circuit, which is most full feature development boards have these two features. This is important to easily connect the ESP8266 to your computer to upload code and apply power. And coming to boot and reset or enable buttons, this is to put the board in flashing mode or reset mode, which means you can restart your board. And then coming to pin configurations and number of pins, to properly use the ESP8266 in your projects, you need to have access to the board pinout, like a map that shows which pin corresponds to which GPIOs and its features. So make sure you have access to the pinout of the board you are getting. Additionally, some boards have more accessible GPIOs than others. That's a factor you should take into account depending on your project features. And then coming to size, there is a wide variety of ESP8266 development boards with different sizes. Some boards benefits from a small form factor, which might be very practical depending on your project features. Usually, smaller boards have a small number of available GPIOs, like ESP01. And then coming to antenna connector, most boards comes with an onboard antenna for the Wi-Fi signal. So some boards comes with an antenna connector to optionally connect an external antenna. So adding an external antenna increases your Wi-Fi range. And then coming to the next slide. Here ESP826612E Node MCU Kit. So the ESP12E Node MCU Kit is one of the most used development board. It features 14 MB of flash memory, access to 11 GPIO pins and one analog to digital converter, which is ADC pin with 10-bit resolution. So in addition, the board has a built-in voltage regulator. You can power up the module using the mini USB socket or the VIN pin. Uploading code to the board is as easy as uploading code to the Arduino. So there is no need for a programmer or extra circuitry as it has a built-in USB to serial converter. Most boards comes with the CP2101 or CH340 chips, which is like USB to UART pin. So it comes with an onboard antenna for Wi-Fi signal and comes with reset and flash buttons to reset the board and put it into the flashing mode. There is a blue LED internally connected to GPIO2, which is very practical for debugging. This is the ESP8266 board model we use more often in our Wi-Fi and IoT projects. It is very versatile and it's great for beginners. So, if this is your first time with the ESP8266, this is the module I recommend you, which is ESP826612E Node MCU Kit. Now, let's see other popular ESP8266 development board. So other very popular ESP8266 boards are ESP01 and the ESP8266 VMOS D1 Mini. While I don't recommend the ESP01 for beginners, the ESP8266 VMOS D1 Mini can be a good choice. Why? Because let's see, in the ESP01 is super small and it fits in any enclosure. So it's perfect for finished projects. However, it is very limited in the number of accessible GPIOs. Here you see, and doesn't have a built-in voltage regulator. So you need to use a 3-volt power source or add a voltage regulator to drop the input voltage to 3 volt. Additionally, it doesn't come with a USB to serial converter, right? Which means you need a programmer or a specific programmer board to upload the code. That's why I don't recommend this for beginners. If you are taking VMOS D1 Mini, this offers 4 MB flash memory, 11 GPIOs and 1 ADC pin in a minimal and small setup. The community has developed a wide variety of shield for the D1 Mini board, which allows you to build small and simple setups with almost no wiring required. You just need to stack the shield to connect multiple peripherals. It comes with a built-in voltage regulator and USB to UART converter, which makes it easy to upload the code. So for these reasons, this might be a good choice for beginners. And there are many other versions of different ESP8266 board. Most board work in a similar way. Just make sure they are suitable for your project requirement. So here you can see the main difference between 01 12E module and VMOS D1 Mini. And if you are taking GPIOs, you have 4. In here it is 11 and here also you will get 11 GPIOs. Coming to ADC, everything have 1 ADC. And ESP01 only have 1 MB flash memory. These two have 4 MBs of flash memory. And it is not breadboard friendly, as I told earlier. These two are a big S. And these two have USB to serial converter, but ESP01 doesn't have that. And these are the size of the boards. So these are the difference between ESP01 12E and VMOS D1 Mini. Now let's see. The ESP8266 12E Chip Pin Out. So a pin out is like a map that shows which pin corresponds to which GPIO and its features. This way you should know which GPIO to use. If you need to use SPI, if you need to use I2C, ADC, if you are going to use I2C, then you have to go for GPIO 514. If you want to work with SPI pins, then you have to go for that particular SPI pins. Here it is. So the ESP8266 12E chip comes with 17 GPIO pins, and not all GPIOs are exposed in all ESP8266 development boards. Some GPIOs are not recommended to use and others have very specific functions. So note that not all GPIOs are accessible in all development boards, but each specific GPIO works in the same way, regardless of the development board you are using. So at the moment, there are a wide variety of development board with the ESP8266 chip that differ in the number of accessible GPIOs like sizes, form factor, etc. GPIO means general purpose input output pins. You can use this as input pin, you can use this as output pin. And then ESP8266 12E Node MCU Kit Pin Out Diagram. So here you have only one ADC pin. These two pins are reserved, so we don't have to use this. and these are the pin, like these are the SPI pins like MOSI, MISO, chip select, clock pin. These 4 pins are assigned for SPI, and this is the ground pin, power pin, enable pin, reset pin, and also you have reset button here. Just by pressing this reset button, your board will reset. Ground pin and VIN pin, here same. This is a deep sleep pin, pulse width modulation. You can use every pin as pulse width modulation. There is no specific pins for pulse width modulation. You can use like 0 to 15 pins you can use as pulse width modulation, but 16th pin you can't use because this is deep sleep pin. Okay. So coming to peripherals, we have 17 GPIOs, SPI, I2C, I2S, UART and 10-bit ADC. So now let's see best pins to use. Which pins is used for which purpose and which pin is used for that particular thing. Let's see. So one important thing to notice about ESP8266 is that the GPIO, which means general purpose input output number, doesn't match the label on the board. In your board it is like D0, right? But the corresponding pin number is GPIO 16. Here it shows like D1, but actually number is GPIO 5, GPIO 4, but its number is D2. Someone is asking what is UART. When we go to the communication protocols topic, then I will explain what is UART, what is USART. We will talk clearly about in later sessions. Okay. So now let's get back to this topic. So this table shows the correspondence between the labels on the silk screen and the GPIO number as well as what pins are the best pin to use in your project and which one you need to be cautious. The pins highlighted in green are okay to use. The one highlighted in yellow are okay to use, but you need to pay attention because they may have unexpected behavior mainly at boot. This pin, the pin which are highlighted in red are not recommended to use as inputs or outputs because this is receiver pin, this is transmitter pin and this is ADC pin. You should not use these 3 pins as input or output. Let's see one by one. So first, which pins are connected to the flash chip? GPIO 6 and GPIO 11. I didn't mention here. 6 and 11 are usually connected to the flash chip in ESP8266 board. So these pins are not recommended to use. And which pins are used during boot? So ESP8266 can be prevented from booting. If some pins are pulled low or if some pins are pulled high, if some pins shows the state of the pins on board. What are they? GPIO 16th pin. This pin is high at boot. And GPIO 0. Boot is failure if you pulled low. And then GPIO 2. The pin is high on boot and boot failure if pulled low. And GPIO 15. Boot failure if you pulled high. And GPIO 3. This pin is high at boot and 1. This pin is high at boot and boot failure if you pulled low. And GPIO 10 and GPIO 9. That pin is also high at boot. So now let's see pins which are high at boot. So there are certain pins that output a 3.3 volt signal when the ESP8266 boots. This may be problematic, right? So if you have relays or other peripherals connected to those pins, some pins a high signal on boot. What are they? Which are GPIO 16, GPIO 3, 1, 10 and 9. These 5 pins are high at boot. Additionally, the other GPIOs except 5 and 4 can output a low voltage signal at boot, which can be problematic if these are connected to like transistors or relays. So GPIO 4 and 5 are the safest to use GPIOs if you want to operate relays. Okay, then coming to ADC pin. The ESP8266 only support analog reading in the particular one pin. The GPIO is called ADC0 and it is usually marked on the cell screen as A0. The maximum input voltage of the ADC0 pin is 0 to 1 volt if you are using the bare chip. If you are using the bare chip, the maximum voltage is 0 to 1 volt. But if you are using development kit, the range is 0 to 3.3 volt because these both contain an internal voltage divider. And then there is one pin called onboard LED, which is GPIO2. This pin. Most of the ESP8266 development board have a built-in LED. This LED is usually connected to GPIO2. So the LED works with an inverted logic. It sends a high signal to turn it off and low signal to turn it on. And then coming to reset pin. When the reset pin is pulled low, the ESP8266 resets. This is the same as pressing the onboard reset button. And then coming to GPIO 0, where it is, I didn't mention here. This one. GPIO 0, this is pulled low. It sets the ESP8266 on bootloader mode. This is the same as pressing on the onboard flash button or boot button. Then I2C pins. The ESP8266 doesn't have hardware I2C pins, but it can be implemented in software. So you can use like GPIO 5 and 4. Fifth pin is for serial clock pin and fourth pin is for serial data pin. And coming to SPI, these are the 4 pins, which is for serial clock 14 and 12 is for master in slave out and 13 is for master out slave in and chip select is for GPIO 15. When we go through the communication protocol topics, I will clearly explain about what is I2C, what is UART, what is SPI. We will learn clearly about it in later sessions. Now I just want to give the introduction of all this. Then coming to pulse width modulation, as I told earlier, it allows all input output pins from 0 to 15th pin. Pulse width modulation signals on ESP8266 have 10-bit resolution. And then interrupt pin. The ESP8266 interrupts in any GPIO except this 16th pin because this pin is used to wake up the ESP8266 from deep sleep. And then power pin. Usually all boards comes with the power pin like 3 volt, ground and VN. If you are not providing power through the USB port, you can use these pins to power the board or to get power from other peripherals. And then now we are going to see how to program the ESP8266. So there are many different ways to program the ESP8266 using different programming languages like C, MicroPython, LUA and others. So our preferred method is programming ESP8266 using Arduino programming language using Arduino IDE. For beginners, I recommend getting started with Arduino IDE. So to program your board, you need an IDE to write your code. If you are just getting started with ESP8266, you can start with Arduino IDE. So now let's see how to install IDE. For that, go to your Google and here search for Arduino IDE download. And this is the official website of Arduino. Click on this. And and go to you can download according to your OS. I'm going to download Windows 10 and newer 64 bits. So you will go through this page, click just download, and your Arduino IDE will download here. I have already installed Arduino IDE. So if you are not having IDE in the sense, just download it. After download, just open this IDE. Your IDE will place in the desktop. Sorry. Okay. So I'm going to cancel this. So after installing, if you open your IDE in the sense, it will look like this. So after downloading IDE, we have to install ESP8266 Node MCU in Arduino IDE. To be able to program the ESP8266 Node MCU using this IDE, you need to add the support for the ESP8266 board. For that, what you have to do is that go to Files, Preference. In this additional board manager URLs, you have to paste this link. How to get this link? Same, go for Google. Here just type ESP8266 package for Arduino IDE. So here go for GitHub. Scroll down and here you will get you get the latest version and here is the link. Just copy this link and go to your IDE, File, Preference, and here you have to paste it and click OK. Then what you have to do is that go to Board Manager and here you have to type ESP8266. You will get like this by ESP8266 community. Check for the latest version and click install. I have already installed. So click install. That's it. So now what you have to do is that you have to restart your Arduino IDE. So close this IDE and open it again. Then go for tools. Check the board. You will get your ESP8266 like this. We are using Node MCU ESP12E module, right? So if you are writing program in the sense, you have to select the correct board and correct port. So you have to click this and you have to select the port also. So I will tell how to do this. So now, for example, I am going to just write a simple LED blinking program. Okay, so here you will get void setup and void loop. Inside void setup, you can give the the pin mode and its function. If you want to execute your program for only one time in the sense, you have to give it inside this. If you want to give your program continuously running in the sense, you have to give inside this. So first what I am going to do is that I am going to define my LED pin and its mode using one function which is called pin mode. Using pin mode, I am going to set my pin and its mode. For example, I am going to take like D5 pin. I am going to set its mode, input mode or output mode. I am going to set my LED as output mode. That's it. So now what I want to do is that I am going to continuously blink my LED. So for that I am going to write some code inside loop function. So inside what I am going to do is that I am going to use one function called digital write. So inside again I have to mention that pin number and here I have to give whether it is high or low. First I am going to make my pin as high. Then I am going to stop my program for 1 second. So here you have to mention the second in millisecond. So 1000 means 1000 millisecond means 1 second, right? So again I am going to give digital write. Inside I am going to again give D5. Now I am going to make my pin low. So again I am going to give delay for 1 second. So first I am going to make my pin high and after 1 second I am going to make my pin low and again after 1 second it's come to this line. I am going to make high, I am going to make a delay, I am going to make a low and again a delay. So this is our LED blinking program. So I'm also going to show you. So is it visible? So I have connected one LED and resistor. What we have to do is that we have to connect the short leg, which means negative leg to the ground and positive leg to the D5 pin. So now we have to upload the code. So I am going to upload this. Make sure that you have selected the correct board and port. If you are connecting using USB cable to your PC, in the sense you will get the port here. So click on this component 5. It's uploading. Let's wait for a few seconds. It's uploading. Yeah. So here you can see the output. For 1 second it will be high and for 1 second it will be low. Is it visible now? Is it clear now? Can you see the screen? So this is our code, this is our output. Is it clear, everyone? So again I am telling you, it's the right time to switch your masterclass into internship. So these are the benefits. You will get 30 days of live session, you will get 90 days of access to these records, and you will get 8+ source code for all the projects, and you can download all the presentations. Every week you will assign for your mastermind classes. You can clear your doubts, you can ask questions to your mentor, and you will get internship confirmation letter, and also you will get internship certifications. And use this coupon code and use this registration link to register, and use this code to get discount amount. It is only $799. So this is all about today's session. Thank you all. Have a very nice day. Let's catch up at tomorrow's session.